Hey everybody, how you doing? I hope you had a great winter break, and I'm going to do my first video lesson in 2 or 3 weeks. So if it's a little rusty today, it shouldn't be, because I'm a pro. But if it's a little rusty today, okay. Anyway, the purpose of this problem, I'm only going to do one example today, is drawing a complete graph, and a complete quadratic graph. Come on, focus. A complete quadratic graph needs to include the x-intercepts, the y-intercepts, the line of symmetry, and the vertex. And it should be noted at this point that all of these problems that we're going to solve in this particular section, this is when the problem is factorable. We'll talk about how to handle a complete graph when it's not factorable. Later on, actually probably in about a week after we learn quadratic formula. Anyway, because this one's factorable, to find the x-intercepts, I would use factoring. So when I look at these are all even numbers, so I know I can factor out a 2, leaving me with x squared plus 3x minus 4. And then x squared plus 3x minus 4, that factors into, let's see, one's positive, one's negative. So it's going to need to be plus 4 and negative 1 to multiply to negative 4, yet add up to positive 3. So then, like we were talking about in class today, if you set this equal to 0, because the x-intercepts, is what is the x-coordinate when y is 0. So we set y equal to 0. And I have 0 times 2 times x plus 4 times x minus 1. And as we talked about in class, you set the different x parts equal to 0. So x plus 4 equals 0, x minus 1 equals 0, and I get a solution of negative 4 and positive 1. So one of our x-intercepts is at 1, 0, and the other x-intercept is at negative 4, 0. All right, y-intercept. Y-intercept is awesome when you're in standard form because it's just you plug in 0 for x and see what y is going to be. And if you plug 0 in for x here and here, these two would essentially disappear. And what you're left with is this value over here, negative 8. Or if you plugged 0 into your factored form, you'd have 2 times 4 times negative 1, which is negative 8. Now, line of symmetry. I'm going to teach you 2 different techniques for line of symmetry. The first technique I use is when it's factorable and I already know what the x-intercepts are. You know what, we haven't even talked line of symmetry. I shouldn't talk about line of symmetry before unless I've talked about vertex. How do we find the vertex when we know what the x-intercepts are? Well, if you think about a parabola, and it's the balanced nature of a parabola, it always looks like the letter U, a perfect U. If your x-intercepts are here and here, the vertex would always be in the middle. So I know that that x-coordinate is the middle of negative 4 and positive 1, and another word for middle is average. So if I go negative 4 plus 1 divided by 2, that gives me negative 3 over 2. So I know that my vertex occurs when the x-coordinate's negative 3 over 2. And then I can just plug negative 3 over 2 into the equation. It's going to be ugly, but it's just the way it is. So y equals 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 minus 8. Let's see, negative 3 over 2 squared is 9 over 4. 9 over 4 times 2 is 18 over 4. Minus 6 times negative 3 halves is negative 18 halves. It's -9, but I need the fraction to work with this common denominator here. -8. Looks like I can go with a common denominator of 2. 18 over 4 simplifies to 9 over 2. This is still just 18 over 2. And then 8 with a denominator of 2 would be 16 over 2. And let's see, 9 minus 18 is -9. -9 minus 16, -25. So -25 halves. So in this particular case, my vertex is at -3 halves, -25 halves. So I guess at this point I could go ahead and start doing my graph. It's positive 2x squared, so I know the graph is going to be going up. The vertex is always in the middle. So I have -3 halves and -25 halves. And then your x-intercepts would be off on the sides. So I have one here at +1, 0, and another one over here at -4, 0. The y-intercept at 0, -8. Well, if this is an x-coordinate of 1 and this is an x-coordinate of -3 over 2, that 0 would be somewhere in the middle. 0, -8. So I've got the x-intercepts, the y-intercept, the vertex, and the last thing is the line of symmetry. Line of symmetry is essentially a vertical line, an imaginary vertical line. So we make it dotted that passes through the vertex. So that lets you know that the left and the right side of the graph would be completely balanced. And it's always going to pass completely through the vertex. And this is the x-coordinate, which is the vertical line. So the line of symmetry in this case is x equals -3 over 2. Okay, that was how I'd go about solving this problem. To finish off with, the vertex, if I was in, if it's factorable, I always just do the middle. But here's another trick to find the vertex. If you have a standard form graph, so if y equals ax squared plus bx plus c, a standard form graph, then the vertex, this is a pretty crazy trick, but it's a -b over 2a. So then the vertex is -b over 2a, and then essentially whatever f of -b over 2a is for the y-coordinate. So in this particular case, b is equal to 6, a is equal to 2. So this vertex would have an x-coordinate of -b over 2a. So -6 over 2 times 2. So -6 over 8, which is -3 over 4. Wait a minute, Elliot's made a mistake. Oh, that's embarrassing. I said A was 2 here, but then I plugged 4 in for A. So this should have actually been a 2, making it -6 over 4, which reduces to -3 over 2. See how quick and easy that was, though? And that's the same x-coordinate of the vertex that I had right here. So it's -b over 2a. So -6 divided by 2 times 2, which gave me -6 over 4, which gave me that exact same value of -3 over 2. And then once you have that vertex value, there's really no fancy way. You just got to plug into the equation. So I guess you hope that your vertex is not a fractional point. Anyway, just one example for you. The whole purpose of this lesson was when you get back to back from break review, it's meant to help you out with this number 5 problem right here. Because number 5, they're asking for y-intercepts, x-intercepts, line of symmetry, and the vertex, the complete graph. Doing this lesson makes me occurs to me that I do need to add one objective onto our list breakdown, but we will talk about that in class tomorrow. So until then, let me focus this one so you guys can get a good view of it. Number 5, focused in. Focused in. Number 5. Okay, there it is. So those are the 3 problems that this lesson is meant to help you out with today. Anyway, have yourselves a great day, and I'll talk to you soon. Bye-bye.